Hi, everyone. We are FlowCellutions, the battery testing company fighting climate change by making renewable energy storage economical. Before I dive into batteries, let me share an analogy. Imagine you're preparing for a party this weekend. Let's say you need the perfect cupcake recipe to bring to the party, and so you probably want to try quite a few different recipes before you pick the best one. But what if you only had a miniature children's toy oven that baked one cupcake at a time? It might take months for you to perfect your recipe. Instead, if you had an oven which baked dozens of cupcakes at a time, it might only take an afternoon. And then you can share your recipe with your family and friends at the party this weekend. This is the problem facing battery researchers. With so many different battery recipes to try, if only toy ovens are available for product development, it's nearly impossible for new recipes to make it to the party or the market. Most of us have heard of lithium-ion batteries commonly found in your phone or electric vehicle, but what about scaled up to the electric grid? Although lithium-ion is the most common battery for the grid, in reality, it does not have an efficient supply chain, and so it's not efficient or economical to put on a large scale. That's why we are working on redox flow batteries. Bloomberg New Energy Finance predicts a 20-fold increase in grid energy storage over the next 10 years, and redox flow batteries are in the best position to capitalize on this growth. Unlike lithium-ion, which uses complex chemistries, redox flow batteries mainly use water, which makes them efficient and safe to scale up. The Department of Energy predicts that redox flow batteries will capture nearly half of the grid energy storage market by 2030. However, similar to the cupcakes, redox flow batteries are lacking critical improvements with screening of new battery materials. That's why we created FlowCell. FlowCell is the oven for dozens of battery recipes.
Our FlowCell is a multi-channel system which provides high scalability. We have cartridges which are about the size of an iPhone, and we have a hosting cabinet which is approximately the size of a mini fridge. Along with that, we've got accompanying software that provides real-time battery testing analytics. So the value that we're providing to researchers is reducing experimental time, materials, and effort while simultaneously providing high levels of flexibility in screening capabilities. So the FlowCellutions market is specifically targeted towards researchers and engineers in flow batteries. Our breakthrough market is academia and government research labs who are specifically trying to screen new materials. And our target market is industrial. So we are expecting our resiliency sensing devices to be used for operational flow batteries on a large scale. As renewable energy continues to grow, so will the demand for flow batteries. And so by capitalizing on the timing of this clean energy revolution, we're positioning FlowCellutions to be the industry standard for screening new materials and resiliency sensing. So onto our market strategy. In phase one, we're looking at using our existing relationships with research labs and improving our marketing and raising seed funding, as well as software development. In phase two, we're looking at expanding our manufacturing pipeline, as well as introducing our resiliency sensing devices. These devices will have similar functionalities to the screening devices, however, they're going to be adapted slightly for different applications. And in phase three, we're looking at growing internationally and continuing our expansion. FlowCell beats out our competitors in a number of different avenues. Firstly, it offers high efficiency and usability while reducing prep time for experimentalists. We're able to achieve low costs due to our fully integrated system. And currently, none of our competition actually includes all of the necessary experimental components to do material screening or resiliency sensing, which leaves our customers having to source the materials on their own, which sometimes limits capabilities and functionalities in their existing system. So FlowCellutions is providing one system that is all-inclusive, which ultimately provides a smoother pathway for material screening and resiliency sensing. And ultimately, our goal is to just get flow batteries out into the market as soon as possible. So FlowCellutions has two revenue streams. The first is with cabinets, which come integrated with software and hardware. And then the second is the reoccurring sales of our cartridges. And so over the lifetime of our equipment, we expect our cartridges to be approximately 85% of our net revenue. While taking into account revenue and other expenses, including operations, maintenance, R&D, and others, in 5 years, we're expecting $53 million in annual revenues and $21 million in profits annually. So now let me introduce to you our FlowSolutions team. We are a group of really excited graduate students with experience in material science, computational chemistry, and battery research. Along with our advisors who are professors at the University of Pittsburgh, we are confident that we are the best team to provide improved screening of new materials for flow batteries and resiliency sensing for flow batteries on a large scale. Onto our roadmap, we started out this process with 2 really big competition wins at the University of Pittsburgh. Then we moved into filing for a provisional patent, and through this process, we've been doing customer discovery as well. To date, we have done 55 different customer discovery interviews, and we have 100 expected by May. And we have incorporated the customer needs into our initial prototypes. And in the fall, we're expecting SBIR funding as well as research grants. And eventually, we'll move into partnering with researchers and industry to be able to get our company off the ground and make this a reality. Even though we are a fairly new company, we are really, really excited to mature and to fight climate change. So save the world. Be part of our FlowSolutions. Thank you.
A question over here.
Yep.
Could you explain resiliency sensing devices and what those are? It sounds like it's a big part of your business, but I didn't hear you describe what that actually is.
Yeah, absolutely. So basically what happens is in a flow battery, there are a number of points where we can essentially test how the battery is doing. And so with our device, we can flow electrolyte through our small system to see if there are any issues with the electricity flow in the process. So when you've got a big flow battery on a large scale, you can input our resiliency sensing devices at multiple points during this electricity flow to make sure that we're maintaining reliable and safe electricity onto the grid. Does that make sense?
Yeah, so is this device actually installed as a permanent device and monitoring continuously? It's not like a testing device, it's actually a physical, it's a part of the infrastructure of the battery system. Is that correct?
Yeah.
Yes, it will be a part of the infrastructure, but we expect that it will need replacement, which is where our incoming costs would be. So you would replace the sensor every so often.
Do you need to use it once the battery is deployed or only during design and development?
So this device can be used during a smaller scale design and development, and then as you scale up, you could keep on using this device and replacing the sensors.
Why would you do that?
So you would need them because over time, they only have a about 3-month lifetime, and so you would need to keep replacing them as electricity throws through them and they might degrade, and so they have a shorter lifetime.
But if I figured out what battery chemistry I'm using and I'm gonna, okay, now it's time to go scale up and build my grid thing, I don't need these sensors in my grid thing, right?
Good point. So our breakthrough market with academia would use this device as a testing system where you plug in chemistries and then you can test each chemistry and determine different properties you need, and then that's how you find one you need. And now when you scale up, you can create the entire redox flow battery system, which is similar to a chemical plant, and so that's where you would insert the sensors into the flow path.
Sorry if I can ask the Colombo question. So the sensors in the deployed array are to tell you when you need to change out some of the system or some of the batteries. Is that correct?
It could be when you need to replace electrolyte. It could
Okay.
tell you
That's what I meant. Right.
Okay.
Thank you.
quite a few things. Yep.
Yeah.
Thanks.
Can you go back to the slide that kind of showed your timeline? I just want to make sure I understand where you're at right now in the development of your device.
Yes.
Right here?
The roadmap,
I
I
think
think.
it was the other one that kind of.
Yep. So while
Yeah.
we're pulling this up, right here. Do you have a question or do you want me to explain?
Yeah, okay, so it looks like right now you've done the provisional customer discovery. I guess I'm trying to figure out where you are right now towards the MVP and what that's going to be.
Yes. So we have 55 customer discovery interviews to date, and we are prototyping our initial flow cell cartridge right now, which is where our provisional patent lies. And so we're working on 3D printing and laser cutting to create this prototype now.
Additionally, we're working simultaneously on software development to try to integrate the back end of the software development for electrical readings that are coming in, and how do you get real-time analysis on the customer side as well.
Could you talk a little bit more about total addressable market size? You had one slide that listed like $2 billion in one segment and a large number in the other, but like, is that just the total battery market size, not just the testing part of the market? I'm confused.
So for our breakthrough market, where we're targeting researchers in academia and government, we get that $3 million figure based on how many current electrochemical researchers there are in the country. And so we took the number of researchers there were and determined how much of budget they have from their grants and things of that sort, and then took how much they have available to get that market. And then for our target market, which would be while they're in operation, we looked at the energy used in the United States over a year and determined how much of that needs to be targeted towards storage for energy. And then from that number, we were able to determine how much is available in that market to store all this energy that we need for 1 day's worth of energy in the US.
But that's not currently all using battery technology right now?
Correct. It's the potential that we have to grasp using our technology.
Yes, we need to meet those targets. So we're anticipating that we will meet them as renewable energy comes on the market.
One last question. Yeah, how quickly can you evolve the number of channels you have or number of simultaneous? And what assumptions are you making about your competition in doing the same thing, and why?
Great. So I'll answer the first part, and do you want to bring up the competition backup slide? And so we can scale up our number of channels easily because it's using the same cartridges that we will be mass producing, and the connections are just electrical connections that are easy to do with electrical engineering backgrounds, which we will have the expertise for that. And to answer the second part for your competition, the assumptions that we have, we looked thoroughly through the competition, and they do not provide all the necessary parts to do a flow battery experiment. And so we will be providing all those parts so that the customers don't need to find third-party equipment and lose the functionality of a test.
We're out of time.
Thank you.
Thank you, FlowCellutions.